Distribution. Why we use them? The Poisson distribution is a probability distribution that expresses the probability of given number of events occurs within the fixed interval of time. Given these events occurs with known as a constant mean rate or independent of the time since the last event. The Poisson distribution particularly use the models is a count based data. We are using the Poisson distribution to model the probability of observing certain number of events in the fixed interval of time. And the example is a parameter lambda is set as a 5, which represents the average number of events of phone calls occurs in an interval. For instance, if you find the probability receives the 0 and 50 calls 5 hours period, we can Poisson probability mass function PMF. The Poisson is a PMF. Yeah, the is a PMF. The PMF is given the probability the observed exact XX and X means the range of 0 to 15 hours. The change in 0 to 15 hours. It's a 0 to 15 calls events in a given interval. Since the Poisson distribution take the non-negative values like integers, I is 0, 1, 2, 3, 4, 5. The proper we can't calculate the how can a calls get from -1. We can't. This is because the Poisson distribution models is a count for of events which cannot be negative. When the when po- when we plot the distribution, uh, see them, they the smaller values 0, 1 and 2, the probability are lower. As we go towards the 4 and 5 events, the probability is higher. For instance, the probability of receives the exactly 5 calls in a 5 hours will be higher. As the number of the calls increases, the beyond the 6 and 7, there's the probability will decreases. Example, why we use them, where we use them. Call centers, the call per hour scenarios. Imagine the call center receive the calls as per example. For the customers, average number of calls receives per around the 10. So calls are independent. One call doesn't influence by others. This is why we have the if this is a value is not get, you can hire some the people, the manpower. Because these calls are increases as they get. The portion applies ideas because the interested in the occurs in counting discrete calls over the fixed interval and hours with average it is 10 calls per hour. Then manufacturing defect on product lines. As an a factory produces the smartphone screens, find this average one, and defect occurs per 100 screens and product. Each screen each defect in a random independently of other scenes. This model help to quality control teams essentially likelihood defects maintaining structures and reduce the waste in production process. Web trafficking, we can also use the web visit per site. Has a news website receive the visitors at average rate 50 per minute. The visitors random independent to arise the one visitor does not affect the others. The portion applies here. We are counting the how many visitors in the fixed interval the 1 minute based on the average of 15 per minute with no dependencies between events. What is the probability of exactly 60 visitors arrivals in specified minutes? What is the likelihood to receive the fewer 40 visitors in exactly next minutes? Knowing this probability help to site administration optimize the server capability, handling the traffic efficiently, and avoiding the crashes during the peak time. Bernoulli and binomial distribution. First, we discuss about the difference. Vernon is a repeater with a single trial or the experimental with the two possibility outcomes of success or fails. A single coin toss, a single quality checks of a product, or a single customer response to survey. So binomial distribution are not like that. We discussed in the previous one. Repeat the number of success of the fixed number of independent Bernoulli trials. It's a combined more than so it's a fixed number of the combinations of the Bernoulli distribution is called a binomial distribution. The number of heads of the 10 coins in a tosses. The number of defective products in the both batches is 50. The number of customers who clicked a link of 100 visitors. Let's discuss about the detail. First, we have the Bernoulli distribution. Already discussed about the binomial distribution in the previous one. Bernoulli distribution is a simple probability distribution. Repeat the random experimental with exactly two outcomes. Successfully usually denote has one is a success, or failure means denote as zero. Uh, in the name, it has cipher stats for the Bernoulli. You can check it. This is one of the example of the Python I mentioned. The classical example of the Bernoulli distribution is a coin toss. The successful is a getting heads as a 1 and the getting tails is a zeros. The plot will explain everything. Heads got the 500 and tails got 515. Sorry, number of success heads is a 515 and number of failures is a 485. But we use the Bernoulli distribution for the rare cases, but most of the times here the binomial distribution works very well, such as the cases. But distribution had a combination of the Bernoulli distributions. We use the binomial distribution most of the times, and geometrical distribution. Let's show you the real example of the Bernoulli distribution. It's one of the easy. I explain you. Suppose you have the factory production of light bulbs. So we want to check the whether a light bulb is defective or not. Success, the light bulb is defective, or failure, the light bulb is not defective. This is a probability of defective, the P as shown in the examples. This means 2% of the lights. Let's show you the probability theorem. Let's say probability of the defective bulbs B is equal to P is equal to 0.02 and 0.2%. This means the 2% of the light bulbs are produced that are defective and 98% of the non-defective. This is random variables that represents outcomes. I call you quality of checks and defective are the from the formula of the Bernoulli distribution within it. And we can also use the email spamming. The email detects as a spam the success. The email is not detected as spam. It's a valid email. This is one thing. We have to use this Bernoulli distribution in machine learning also. Geometric distribution is a discrete probability distribution that models the number of needs to before the first success in the series of independent the Bernoulli trials, which is each trial has a two possibility outcomes, success or failures. This distribution is used to describe the situations where you want to know how many trials it will take to achieve the first success. Like in this the geometric in this order to answer the questions like how many trials do you want to conduct before the first success. I show you the example. There are the two possibility outcomes. Each trial has the success or failures. The trials are independent, meaning the outcomes of the one trial does not affect the others. The probability has the probability of success on any given trials depends upon the p is constant as a p. The number of trials is for success for the geometric exponential formula. This is we can use this plot them. A number of average of the trials get the first success is 4.97 as a 4.973 means this is a simultaneous trial. Since you are the generating the 100 random trials using the some of the variables in the result. This means these simulated trials might be slightly higher. This is a lower. The theoretical means the value is closer to 5 or the 4 have to take the roundup and 5. The random inheritance simultaneously. This is the average number of trials need to first access the little higher, but the this is theoretical value where we use them. Application like a geometrical distribution, the flipping the coin, that's not a good example. The quality control in fact is how many items do you need to check the before you find the first defective ones. And customer service, if you want to try the reach the customers, how many calls will it takes to connect with the assuming each call this is a fixed probability of success. And medical trials In medical trial, how many patients we need to treat it before the first patient experiences the positive outcome. And then negative binomial distribution. The negative binomial distribution is the discrete probability a model number of trials need to achieve the fixed number of success the sequence independent and identify the distribution, the binomial distribution. Sorry, it's a Bernoulli distribution, Bernoulli trials. So it's a Bernoulli trial, the trial which is only two possible outcomes, success or failures. Using the geometric distribution, we model the number of trials using the first success, and the negative binomial distribution, the number of trials need to achieve the fixed number of successes. If you how many trials it will take to achieve the success, like how many times it will take achieve to remember this formula like this. And this is the example. The two possibility outcomes is success or failure. The trial is independence, meaning the outcomes of the one trial doesn't affect the others, as the same scenarios as the previous one. You can run this. It's 11.5. Result based on the 1000 simulated trials. This is average number of needs to get the 11 attempts. Control the negative binomial distribution, how many items you distribute until the certain number of the favorite items. How many sales you can the marketing, how many sales you need to marketing before the certain number of sales. Yes, how many customers interactions are they required to solve this fixed number of customer problems and media cost. How many patients need to treated before the achieve the fixed number of successful outcomes. And the next we have the hypergeometric distribution. Discrete probability of given number of successes, the fixed number of trials. Rather following the finite population with the replacement, it is used to when you are the sampling from the population where the two types of items, success or failures, and you want to do the replace the items after they are drawn. The finite population key features, the population is 7 and the total number of success women is 7 as the number of the five the samples. This is the gotten 3 women. This words they are about in 6 chances of getting exactly 3 women in the random selection of the 5 people in the population. This is also used to quality control. For example, selecting the item without replacing the counting the how many defective items are found. In a lottery, if you want to draw the tickets from the finite populations, you are intersect in the probability of drawing the certain number of winning tickets. In the biological student studies, in the generally it could be the model of the probability of selection certain numbers of gen type of the population.